Good evening, everybody. This is my stream, and we're making a tiny programming language today. It is a huge endeavor to make a real good programming language, to make a real programming language, or to make a good programming language. But to make a very small and not necessarily so great programming language is not that hard. I've done it numerous times. It's fairly easy. All you need are 2 stacks and a dictionary and well, you'll see. So we're going to just jump right in. We're going to emulate a little computer. We're going to make a language in the style of Forth, but inside of this program that I'm building here in Smalltalk. This is a drawing program. I'm trying to build this diagram, or rather a simplified version of this diagram. Just to give you an idea of what we've got so far, we've got this drawing tool, and then I've written a Smalltalk class that is very similar to the language I'm about to build. It has these methods, and you just chain the messages that you want to send together. So we're going to send in reverse Polish notation. When we run it, we get x0, x1, x2. Basically, these names are popped onto a stack. Maybe I'll make this a little bigger. And then, oops, sorry. Then they are XORed. So then the last 2 things on the stack, x1, x2, are then XORed together with this. This is the symbol for XOR. And then that is ANDed to the other thing that was on the stack. So basically, these get combined into a new node that is the XOR node. And then now the stack contains XO and the XOR node, or X0 and the XOR node. And then those are ANDed together, and that produces this thing. So that's pretty straightforward. That's basically, I built this language ages ago in, I mean, it's hardly something you could even call like my own creation. This is reverse Polish notation for logic, right? This is what it is. But I've implemented this in my package for logical, for solving logical expressions, which is called Bex. It's a Rust program. It has a little shell. You type it in the command line, you get this kind of stuff. It doesn't have a graphics aspect to it. That's what I'm building now. This is a completely new thing, Smalltalk related. It's been, I started digging into Smalltalk because I wanted to write some visualization tools for Rust, for Bex, and just kind of got carried away and built a whole little drawing program with, the selections and things to align the things that you draw and whatnot, and you can do all kinds of fun stuff with it. So there you go. You can also have now a scripting language to build diagrams in it. And then what I want to do is make an animation, and it is an animation tool. And you can make, I don't actually have the animation bar showing here, but you can actually make like hand-drawn animations. And I'm probably going to do some of that, but I want to be able to incorporate them into a programmatic structure so that I can write a program and then animate what that program is doing. And so what I've got so far, I guess this is that, but I've come a little bit further now, and now I'm going to show, the idea is that I want to animate the concept of what's called Shannon decomposition, where you're going to take this expression of 3 variables, and then we're going to say, well, okay, if this variable, we're going to branch on this first variable and say, well, if it's true, then it looks like this, and if it's false, it looks like this. And so that causes this to come up. So I'll just step through it. So that's the steps for doing that are to duplicate. Okay, so we're going to duplicate. I guess I can put it up here. We're going to branch on X0. That makes this diagram up here. Then we're going to, in the high branch, this is the high branch, this is the low branch, so this is where it's true, this is where it's false. In the high branch, we're going to set that to true. There you go. In the low branch, we're going to set it to false. And then repeat. We're going to duplicate on the second variable. So now we're going to duplicate again. We're going to branch on X1, and then true and false, and then duplicate, branch on X2. I know you can't see it, but that's the whole idea. So it makes this big thing. And then I guess we go all the way to the end, then those are set to true, those are set to false, and that's the end of the animation. But we want to organize this so that, or rather, this is not actually the end of the animation. This is one way of doing the animation, and then what you get is the inputs to these things then have to be simplified, right? So now you can evaluate them with the with these. So you could say, well, false and this is false, so that's going to be false, and then well, true and this is whatever this is, which is just false. And you can go through this whole thing and evaluate each one of these nodes. But you can also do that while you are simplifying. Like while you are making these duplications, you would wind up with a much smaller tree if you did this first duplication and then simplified both sides, and then now you would copy something much smaller, and you would wind up with something that is much smaller when you're done. So the end result is that you wind up with a single variable down here. All three of these layers would be collapsed into a single layer that had only as many as these whatever this is. So 8, 1, 2, 3, 4, 5, 6, 7, 8 boxes here that either had a true or false in them, and that would be the truth table for this thing. So that's kind of the animation I want to build, and I want to be able to show it both ways. So I'm going to make a short that has the simple version of the animation where it's simplified along the way, and then I also want I'm going to make a number of videos along this way, but like I definitely want to step through this and use this example to show it, like just compare and contrast the two ways of doing it, and like animate both of them. So that's a lot of stuff to animate by hand, but it could be composed into a lot of animations and into a lot of simple animations. And I think it shouldn't be that hard to do. But you got to write a program to do it, and I've been thinking about how to do that. And the basic idea that no matter how you do this, whether I come up with my own language or just keep using Smalltalk or whatever, the basic notion that I'm looking for here is that you're going to run a program, and the output of that program, either happening in real time as you step through it with like a debugger like thing, like I was just doing, or just as a result of running the program, you're going to get a sequence of basically it's going to generate a script that can be used that is only composed of a flat list of these very simple animations. So the output might be something like perhaps we run through the whole thing and then we know what all of the nodes that are going to be on the screen, but then like maybe some of them turn into like for example, when this collapses to the value false, well, the value false is going to be up here. So we bring that to the front. I mean, one way we could do it is just change this to false. So that's O, 0. And then just delete everything else, right? True and false is going to be false as well. So, same thing. I forget where I was going with that. I kind of got distracted by the the drawing. Oh, right. But the point is, yeah. So rather than delete them, you can change these nodes as they go around. Like there's not like a separate class here for like and XOR and true and false and everything. It's all just node or Beck shape, and then you get to choose what the symbol is. And so by changing the symbol, you can change that node. So basically the graph is going to be there, and then some of these things can be hidden, or like rather than delete them, they're going to be animated as like falling away or exploding or whatever. And so the thought would be that you would create them all, put them all in the scene, and then generate an animation, right? So the animation would be, the things that say, change this from this to this. There might be something that says, highlight a particular node to like show what we're looking at. More likely than not, there's going to be some instructions for moving a camera around. So you could imagine there would be like a little box here that is moving around and looking at different parts of the thing. And then when you rendered it, it would show that whatever's inside that camera's point of view. That's kind of where I'm at. That's kind of what I'm looking to build. And so I wanted to build a language for this. And I started out here, and I have this. So, so the idea is, these steps right here, I was able to step through in the Smalltalk debugger. The swapping, when it replaces the variables with the symbols for true and false, that's easy. But when it comes to simplification, well, let me step through it again, and we'll talk about what it should look like. So this is all just straightforward, build. And then when we do this one, like I want to, it's not like what I was doing before, is just clicking this step over button, right? oops, I'm sorry, I'm highlighting that word simp high, so that's not what I want. I want to highlight the whole thing. Come here, that again. So dupe, that's easy. I actually want that to be a complex animation though. So dupe is going to be a complex animation, and I don't want to like necessarily like mix in all the code for doing this like logic here with the animations, right? So the next one, draw that. That's going to be an animation. That's going to be like a transition animation. That's going to be a transition animation. And then, so now we're here on the word dupe. It's a little hard to see, but that's underlined. And then we're going to branch on X1. But what I actually would like to do, I put it down here, but so then the next call really should be like simplify the high branch. And so the high branch here, like this is actually where I want to stop. The high branch here is now the high branch where we branched off of here. We've got and so this is the symbol for and. This is true. So true and something is just that something. And so what should happen is that this, let's see if I can do the whole thing without destroying it. Let's see, delete that gets deleted. This will get deleted. And then this will have a line going from here to here. And that line should be a solid line with no arrow. My little the destination marker is none. Oops. Destination marker is none. There's no ordering on these things, so they just kind of appear in whatever order they want. So it should make that, right? And so that's a lot simpler. And so we don't have to worry about propagating that true value here. Likewise, this is false and something. So this, as I said, should just be false. And then all of this goes away. How you do it? You do it like this. You say delete. UI on this is not great right now, but there you go. And so then it simplifies down to this little graph, which then gets copied, and then that's simplified and and branched and simplified. So, and of course, when we branch that, we're only looking at one side of this, and so there's fewer things to animate. There's fewer things to do, and that would all everything that I just did would be encased in this call to something called simp high. And I want to be able to like debug this animation, like pause at a particular point in this animation, and I kind of went back and forth a couple times thinking about, do I want to do this in Smalltalk? Because I could, that could easily just be a function call, but I feel like I would like this to be, I'm going to be doing enough of these animations that I'd like it to be scriptable. And I don't know, I thought it would be cool to make a video about, about making a small language. So I guess I get to subsidize some of the work, I tried to find a downside to doing this, and the main downside is I might be over-engineering things a little bit. But given what I want to do in the future, like I'm probably over-engineering for this specific problem, but like I can tell I'm heading in this direction, right? So I want something scriptable for these programs that I'm writing. So we'll see. And I think I can hang a lot of ideas onto this. So I'm going to go that way. It's not that hard to make an animation. I can do it. I mean, I'm sorry, to make a programming language like this, it's very easy. So we're just going to do it. So with enough of that, I guess that's enough of that. So basically, the idea is that we're going to take, well, okay, I already have something here, and it already is like the interpreter. So all of these things are now Smalltalk methods that are going to be primitives of the language, right? So these are like if you imagine that we're building a virtual machine, which we kind of are, these are the instruction sets. Except probably swap high will probably be, so swap high was the thing that just looked at the entire subtree here. Like, so basically look at an entire subtree and replace like every time you see like X1, replace it with true, right? Like that's what it means. Except it knows what the branch variable is, right? So in this case, it would be X0, and then when we do X1, it'll look for swap high will look for every version of X1, on the high branch of the current node, and then replace it with true. And swap low replaces the low branch, everything on the low branch with false. So again, this is the low branch right here, and this is the high branch right here. And so what I want to do is I want to have all that processing happen, and then basically it's going to end with, emitting a triple that says like, okay, each one of these nodes has an ID. So like, it's going to say like, well, ID 0017 symbol is going to be false or whatever, and that's it, right? So basically, it's just going to be a set of instructions to the drawing. No, we're going to lose all the semantic content, and we're just going to have like an animation, right? The set of instructions for how to change this drawing going forward. That's the plan. And then when it deletes things, rather than actually delete them from the scene, because you want to be able to scrub back and forth, you don't want to actually delete them. You want to just like hide them or like move them off stage or something like that. So that's the plan. That's where we're going. And let's dive into actually writing some code. So basically what I want to do is I want to take this object that I have now that has all this stuff, and it already has the stack. So if we look into like dupe, you'll see that there is a thing called self push. So push. So first of all, we're talking to a Beck's base, which is the thing that makes these the semantic notion of these nodes. It's building the AST, and it's actually building these drawings. So the in Beck's, in the actual Rust program that I write, a base is just like a graph database of nodes, and so it's just data in memory. Here, it's a simplified version of that because I'm doing it in Smalltalk, so it's all object oriented. In the Rust version, it's very, very optimized, and like you're just dealing with little pieces of memory and everything. But this is just building objects in memory, and they're actually drawings. Right? The drawings are just contain all the data. So I'm kind of blending the notion of a view and a model here. Not necessarily the best way to do it, but it was quick and dirty. I was trying to push through this and do the simplest thing that could possibly work, trying to avoid any kind of over engineering. But the more I looked at this, I just really wanted to make a. It just seemed, my brain just wanted to go there. So that's what I'm doing. Anyway, so when it says self push, that really says stack push, and push is just you have an array and you just stick something on the end of the array. So you can imagine a stack and you're pushing things down to it. You'll get it soon. If you don't know what I'm talking about, you probably do. If you're watching something about building a fourth like language, you probably know what that is already. And if not, well, welcome, and it'll become clear, I think. Okay, so right, so basically the very first thing is just make whatever the representation of x0 is. X0 is an input variable in my language. Push it onto the stack. I'm just going through that same exercise of explaining what the machine is doing for every one of these pieces right here. Maybe I'll make it a little bigger yet again. Maybe even bring this up a little bit, and okay. Oh, I can't open these. Okay. So in that case, we will, can't even say what it is, but I know what it is. It's in Beck's RPN builder. And if I browse that class, I can browse the code over here. So we say x0, x1, x2, and all of these, all they do is they just push whatever the base makes up, which is actually this drawing, the object representing, or rather this drawing right here. This is x1. So this creates this, or created the original version of that. X2, there's all the way up to x4 because there's 5 possible input variables in this little language. And then when you say XOR, well, that executes something called binop, and binop is just going to take one thing off, pop one thing off the stack. That's the opposite of pushing. So push, you pop it off the stack, you pop the next thing off the stack, and then you're going to tell the base to run an operation, which is given by that symbol. So binop is provided by this symbol right here. This is the Smalltalk syntax for a symbol, which is like a string, but slightly different, like an intern string. So this symbol right here, XOR, gets passed to the binop operation, and then that gets passed to the base, and the base, well, basically makes this, right? So when you say XOR, it says, well, I've got two things on the stack. Well, actually, they're passed in here. So the RPN realizes there's two things on the stack, takes them off the stack, passes it to the base, and says, okay, here's that node, this node right here, here's this node right here, and I want you to now create this node and draw these two lines. So that's what it does, and it also looks at their positions and figures out the right place to put that in so that it looks a little nice. So it lays it out. Basically, it basically averages their horizontal position and then moves up a little bit. And that's the logic there. And that's how all the trees are built. Because when the next thing is to call and, well, okay, so now, so these things have popped off the stack. So now we have X0 on the stack, and now we're going to take this new node, the XOR node, and we're going to push it onto the stack. So now we have the X0 node that was over here. I guess I could restart this. And so that X0 node is now going to be, so when we call and here, it creates this node right here. I could, I guess, debug this and it would do the same thing. So you see X0, X1, X2, that's your stack. Then XOR created that. And then, so that's exclusive OR, has nothing to do with the X's in the X0, X1, X2. And then and creates that node. So that's okay. I really like being able to do that, to be able to step through and just like show what the animation is doing, and you just not just for expository purposes, but for like prototyping the talk I want to give. Like, you know, I want to boil this whole animation down to like a, you know, when I spoke it out, it was like 30 seconds, and I'm maybe advanced to like 50 seconds when it's got the animation. So it's going to be like a YouTube short for like this one thing. That's like my goal, is to push this one thing out of the animation pipeline here. So that's where I'm at. Okay, so you get what's happening. The stack is just a data structure. So when you initialize this RPN builder, you just ask Smalltalk for a stack. It's just built into Smalltalk. Pretty much every modern day language has this, has some kind of array thing. Python, you just say push and you say, I guess you say append and you say pop. Actually, Python has push and pop. JavaScript has, no, Python has append and pop. And then JavaScript has push and pop. Yeah, so it's usually that. A Rust vector has like, you can pop first and pop last, I think. I forget what the words are. But anyways, pretty much any language you have, you can do this. And pretty much any language has a dictionary. And so then all you need now is to make a little tokenizer. What we're going to do is we're going to take this and turn like this string, for example, into a program, right? So we're going to say RPN run, and we're just going to give it a program, right? And we're going to say X0, X1, X2, XOR, XOR, and it should run that same command, right? So I'm asserting that when I run this, it's going to do the exact same thing as what this does. That's the goal, right? And how are we going to do that? Well, we're just going to break this and take this string, break it into tokens, and we're going to run each token, right? And the way we're going to do that is we're just going to call the method with the same name as the token. That's the easy part, right? So far, this is easy. So we're just going to do that part real quick, make sure it works. All you're going to do is split the string on spaces. That's how forth works. And you might think, well, what about strings? What about comments? Well, the comment character in forth is a left parentheses, and you just put a space after it. And so then you just don't put a end parentheses in your comments. Likewise, a string, you just use the double quote character, and that starts a string, and then you put a space after it, and then it just reads until it finds an end quote. Forth is a little bit different from what we're doing, because forth actually the interpreter, the parser, the lexer. It's hard to call it a parser because there's not really much to it. It's really a lexer. It's like basically looking for the next token and reading the input stream. That's actually built into the language. So So you can dynamically change that lexer as you go along, or that you can query the input stream as you're going along. We don't need that for this. I have no strings in this language. I'm not dealing with strings. If I were, you could put underscores in there or something, do something like that. So all I'm going to do is I'm going to split this string, right? The only string I am using is the Smalltalk string I'm passing to this little machine, right? So all we have to do is we have to create a method over here called run. So we're going to create a method run in RPN class builder, which I guess is putting it in here, doing it inline. And all we're going to do is we're going to say a string split on. Is that how it goes? Split on space. And then collect. No, not collect. So just to as a sanity check, let's go up here. I'll just run the same thing. So, did I lose that? No, I didn't. Okay. So we'll say just hello world split on space, and I'm just expecting that to return an array. Yes, it does. Order collection hello world. I could have done that here, right? No, I couldn't because I don't know what a string is. Split on a string or split on a space. So that's what we want. We're going to get two of those things, and then we're going to select this. Sorry. We're going to loop through and do something with them. So do is the word that I'm looking for. And then for each one of these little tokens, we're going to say toke as symbol. Let's leave them as strings. I think for this case, normally when you're dealing with this, you might have to deal with like numbers and stuff. I don't think there's any numbers to deal with. I don't think I'm gonna have to write any numbers in this language for the scripts I'm writing. Even if I did, I could turn them into a symbol. Let's just leave them as a string for now. That's the most general thing, and then we'll send them. So we'll say run token. So we'll say self do token. Okay. So that's what run is going to do. We're going to take whatever we get, we split it on spaces, and then for each token, we're going to run that token. This is like map for each, right? Okay. Now we add do token, and then that's over here too. So now we have run over here, and then we're going to have do token. Let's call this execution. All this does is, as you're browsing around, I have a lot of stuff in here that probably ought to be called something else. Execution is going to be this thing. So do token is also going to be part of the execution framework or protocol is what this is called. There's no semantic meaning to this other than it's just a way to group all your code. And you don't write code in a text file. You write it all in this user interface, and then it's basically in a database, and you serialize it out to disk. All right, so do token, and we're going to call this a string. And so now there's basically going to be two cases. And the two cases are either it's going to be a primitive, it's going to be one of these, like some unary function, because we can't do like this where it says binop. We can't pass it an argument. At least not this way. We're not going to be able to pass it this way because this is all Smalltalk. So anything that's a unary operation, I'm going to call these ops. Okay. So I'm debating in my head like whether I want to allow adding these dynamically, because if I see, okay, so what you can do is you can say, okay, well, a string as token, and then you say self perform a string as token, and that will work easily, right? That's the easiest thing you can do. So this is like so it's an object. This RPN builder right now is a class, but at runtime it's an object, and it has a method dictionary, and so you can look in the dictionary and say, well, are any of these basically, you know, so if I have the string x0, it's self-perform the string x0 as token is going to run that thing. So actually, this is it. This is done for the use case that I've written so far. Like, this is done. I didn't really call, and this isn't really a test case, but look. So if I just run this, okay, it's brand new, it's empty, and I run this now, I believe this will work. Oh, byte string did not understand as token because it's not as token, it's as symbol. I love how you can just change this right in the debugger. Basically restart it and then play, and there you go. So that worked. So we don't need this anymore. This was just an example. And we don't, like, basically this now, these two things are now equivalent. Okay. And then, can we make a multi-line string? I believe we can. Strings are multi-line in Smalltalk. So now I can say dupe, but I can't translate this line because branch on x0 takes a parameter, and I can only pass in a single token. So let's make a new function called br0, and then we'll say swap high, and then we'll say simp high, and then swap low, and then basically the same thing. So we're going to copy all these. Actually, it's the same thing right here. So we'll copy this. It's three things that are the same, which might make you think that we need to do some parameterization here. And maybe we should. But, and this should be br2. Okay. But I can't run this yet because I don't have these two things. So if I run this, this will probably say that br0 does not exist. Let's start over and then run this, and then I would expect. Oh, also it's going to screw up the screen, right? You don't know this yet. It's going to screw up the screen. So if I run this, not understand and. Oh, because we've got a new line in here. Okay, so that's a new thing. So so inside of run, excuse me. That should let me click on that. Not responding. Oh, maybe I have to. I'm a little surprised. I would expect that to. Yeah, so I don't know why that didn't work that time. All right, so really it's a string. There's just a split. Split words? No. I want to put on white space, any kind of white space. All right, so let's do this split. All right, so first of all, a string. If I say A space 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 B, this problem is not a space. There's a tab. But the problem is that the tab, the new line character is being put in there. So let's just put this outside of this for a second. I just want to evaluate this split. Dude, there's not just a split. Is there words? Split as word array. If I print that, I think that's actually 16-bit word. Yeah, that's number. Tokens. I know there's a way to do that. I might even let's ask Google if there's a way to do that. Pharaoh, small top, split, string on white space. Substring. Weird thing. That's what I wanted. Okay. So that actually solves the problem. I was going to say, well, strip each one, but no, substrings is so a string substrings do, and we don't even need the parentheses anymore. So do token, self token, do that. Okay. Substrings. Way to do it. Okay. We're going to just start this over. Might be able to do it the other way, but boom. And now we're going to run this again. I'm expecting all of these to run, and it's going to complain because it doesn't know what BR0 is when we try to perform BR0. Yes, does not understand BR0. And so we can just set this aside for a minute, and then we can go over here to branch. What we want to do is branch, and we're just going to say BR0 is self BR branch on X0, symbol X0. I'm going to call this an op. We're going to make all of these ops in a second. All the unary ones are going to be ops. Just for organization. So then same thing for BR1. A little redundant. And BR2, and I'm just going to make all 5 of them. BR3. And BR4. There's only 5. I don't mind making 5 copies of things. Okay, so now this should work. I think I just proceed, right? User data was sent. I didn't like that. All right, so I got to restart it. I think I could have hit the back button and restart. Boom. Okay, so that worked, and it did do what I expected it to do, which you probably did not expect it to. Come on. That's a bug completely in the wrong. It has to do with the zooming. What is the way to do that? How do I fix that? Scene. I forgot. I should have. I need to add like a word for that. I don't remember how to recover from that. I think you just set the transform on the scene. Scene transform do, and then just replace it. Nope, that's not it. I don't remember how to do that, so we're going to kill this and start over. But it's really easy to start over. Fetch, fetch out. And then all your notes are still here and everything. So, yeah, I don't know what I was doing there. I got to fix that. I just don't have it on top of brain here, and I could have debugged it, but I don't need to. So I'll save that for another time when I'm not on camera. All right, so now if I run this, I expect this to work, but again, be off the screen. Things are going to be flying off the screen. So that worked. Maybe the simple fact that those are off screen is what's causing the issue to happen. First of all, I don't need this because that's duplicated. So that's, and then here we're going to run this again. And I'm going to zoom out. I want to select it. Graph tool selected. So we got to close this. I don't have a keyboard shortcut to delete yet, so I have to do that. I'm going to just move these back into the scene. and then hopefully it'll behave itself. No. What on earth is happening there? You do this like this, and then when you zoom out like this, oh, it's like the scale at which I'm doing things is so off the chart that, yeah, these numbers are just getting huge up here. These are the coordinates of my space. Okay, so I have a bug in here that's causing my attempt to drag the scene around to just be like, the scaling is just completely off. So I have basically the fix is I got to scale it back to normal, and then I'll be able to move it however I want. So that's a silly bug that should definitely get fixed, but not something I have to do with today. So I'm just gonna, oh, I can't do it out here. I have to do it like here. I can't adjust the scene until I zoom in. Then run this. Beta software, alpha software. Sometimes you got problems. Okay, so we're gonna move this in here. Now I'm gonna zoom in just anywhere, so it's normal size, and then I should be able to move the. Ah, it's still screwed up. Ah, well, that's unfortunate. Okay, well, it doesn't matter. Let me explain what there's this two bugs working together. So the issue is that some of these things, the way this graphics framework works is there is uh, shapes do not know their positions until they're laid out. You tell them you tell the shape to relocate to say a particular place on the screen, and then you ask it what its position is. It's always going to say 0. It's always going to say it's at the origin until it's been laid out. And when you do these steps, everything's easy. But when you do this duplication, it's copying a bunch of stuff and adding them to the scene, and then like basically saying, copy them over like, whatever the width of the selection is plus like 50 pixels, right, or 50 points. And so then these two things are now side by side. But then once you do the next step, we haven't given the thing time to refresh itself. And when we were stepping through it in the debugger, everything worked fine because the debugger is like running in a separate thread. And so it's able to send the message to draw the stuff. And then, unfortunately, right. And so then everything looks fine on the screen. But then here, there's no time in between the running of the steps to allow for the image to catch up. And so it's running faster than the image is able to process events because basically it's all running in one one step without any kind of like pause, right? And so I guess there's two ways I could do that. One is that I could go in and I've made some attempts at this to like fix it. I don't want this behavior. This behavior makes perfect sense when you're making like a GUI system, but when you're making a drawing tool, like I run into this issue all the time. And basically, you just have to like do things in 2 steps, and like basically do like a callback to say, okay, after you refresh yourself, come back and do the next thing. I don't want to mess with that. I don't want anything to do with that. I want to pretend that is not the case for the canvas I'm drawing with, and so I've made some attempt to work on that problem. Yeah, but it's not solved yet, and so The question is, what do I do instead? And I'm thinking what I do. Well, I want this to be like an active object in the scene, right? Like, it has nothing. This has nothing whatsoever to do with. Oh, okay. What I want to do. Let me. I've got like a little traffic jam in my head here. All of these things so far, up until this point, up until swap, are easy, and swap is actually fairly complicated. It's a fairly complicated thing. Branches is not really that much more difficult. All it's doing is, well, okay, first of all, it, like if you branch on x0, it's going to draw the x0 square and then say, well, okay, actually give it a rounded, round the corners until it looks like a circle, and then actually build these what is this incoming? Oh yeah, so it actually draws the this should probably be in the base, not the RPN builder. All of this graphic related stuff should be in the base. In fact, the word branch should probably be in the base. But in any case, it draws that thing. We could think of this as a primitive. Maybe adding an edge would be a primitive step, because I guess if you want, okay, so again, it's our choice what to make primitive, what not to make primitive. But the reason I would say this might, I guess the primitive steps would be anything that might have its own animation. So like drawing the circle is one step, and so like really that's drawing the node and making it a circle. Like that should all happen in one step. And then drawing the left branch and then drawing the right branch, that's a step. Duplicating the thing is a step, and then so this is, there's a little bit of work going on here, but conceptually it's really those steps: draw the left hand branch, draw the right hand branch. And then when you get into swap high, which is walk the right hand branch, walk that entire subtree, and anytime you encounter the current input variable, then replace it with the whatever you're replacing it with. So in this place, replace it with the true symbol. I call it capital I because it looks like a 1 in Bex. Rust program. Okay. So what I'm going to do, I want to put something on the screen, and I want it to be, I want to basically have a set of tokens up here. I don't really use this inspector much. So let's start over here. So let's go to a Bex app. So we're going to browse this whole class. We're going to make an arranger. So that's a GS arranger panel. Browse this. I think it's just, you just subclass dockable, GS dockable. Then you add whatever you want in here. This is actually pretty good, pretty close to what I want. I'm going to want like a step button. I'm going to make like a little debugger. So we're going to, let's copy this. We're going to make a new class that is a thing. So rather, in addition to the sketch panel, we're going to say add dockable. So we're going to say, put it at the very top. We'll say add dockable self make debugger as debugger in and in the right doc. So save that and make this. We're going to create the method make debugger. And then so we're going to say something just like this. So we're going to say debugger, is, which we need to add to the class. So we add this to the plot debugger in Bex app, and we're going to say Bex debugger panel new. And then the RPN builder, RPN is going to be just our RPN, self RPN. First, create that class. Just like this is going to be a subclass of GS dockable. As I say it out loud, sounds a little bit like it ought to be a trait, maybe. Whatever. Maybe it would create a dockable component. All right, so then create this method in the Bex debugger panel. And we're just going to say an RPN builder. And our RPN is equal to an RPN builder. And this is a plot in the Bex debugger. Why doesn't this have an RPN? Oh, because this is not something that's part of the class. I've just been making this. So this is something that probably now ought to be part of the Bex sketch app universe. So let's add this to Bex sketch app. And before we make the UI, so in initialize, before we do the super initialize, we're going to say RPN is equal to Bex RPN builder new. And then after we do all this stuff and we've created the scene, we're going to say RPN base and here I assign it to a variable, but I never use this, so this is unnecessary. And then we don't need to clear the scene. So we're going to do this. RPN base is Bex scene builder new with our scene, so with a reference to our scene. Okay. And now when I do this, I can just say scene clear to do all that because RPN will be a child of it'll be a local variable in this application because this is a Bex sketch app. If I close this and just rerun it, I need this GitHub stuff open. And this is something I was working on in a previous stream, talking to OBS. It was about, I made a controller for OBS to stop and start recordings in Free Pascal, also for this animation. So check that out if you haven't seen. Bex sketch app. Now I create this, and I would expect this to just run, and again make the messy scene. So now because now the RPN is just part of the scene. Everything is fine there, right? But just when I move it, then when yeah, you can already see it's starting to get jumpy at that level of zoom. Got to keep it zoomed in. Okay. Okay. And now we have a GS dockable here, which is actually our RPN panel. So I'm going to, how do I do this? I can just browse anything and then change from here. I go to Bex, where Bex debugger panel. one I just made. That's what I want. And is our RPN builder. If I click on this, I can see other things that are in here, but I think all I need to see is, I'm looking for what sets the text of that. If I look at it, this. Oh, I gotta click on the class hierarchy. So I can see what the animation panel does. The inspector, that's simple. Initialize. I think I copied a minute. Now I can, since they're both GS dockables, I can use this as a template to make it, make the initialize for this method. So super initialize, copy the whole thing. Do this. So super initialize, and the title is going to be debugger. We don't need to do anything. So this is from the arrange panel, and what the arrange panel does, the arrange panel is this one. Rid of this. The arrange panel is this one right here. Pull this out. And what it does is it's all of these are methods on the selection box. So align the tops, make a row. These are all things that the selection itself knows how to do. And so if you do this and you say make a row, it's going to make them into a row. And so all it's doing is inspecting that class and listing out its methods. That's kind of neat. Nice for the drawing tool. The inspector also dynamically inspects the thing you click on, and it looks at the different fields for that particular kind of thing, and get different little, can't see because there's no way, but you get a little form for editing it. You dock these in different places. Kind of has a weird interface where you drag this little circle to resize it, and then that resizes the panel. That's clearly not ideal, but that's how it works at the moment. Anyway, so we've made this debugger. So we want to make something in the debugger. And so but I guess the point is that the work area is this white area, and then this thing up here. So I can put whatever I want in the work area. And what I want to put in there, what I want to put in there are the words, and I want to put some buttons. So I want to put some buttons that allow me to step forward. And then underneath it, I want to show the words that I'm stepping through. Yeah. So kind of the structure in Bex for these these Bex is a language for defining like operations on Boolean expressions. So it's the language of logic, and you can make ands and ors and XORs, but you can also just make any function of inputs and outputs. And so it's stored as a graph database, and the structure that I use for the graph database is actually very similar to the structure you would use for, like, it literally stores them in RPN format. And so it's just like very, very similar. So I'm seeing a parallel between like the graph structure itself in the database and the and what I want to build here. Right, but, okay, so basically what I'm picturing here then is a list of, they're going to be symbols, right? So it's going to be a list of symbols, and we're going to see whatever the current list of symbols to run is going to be in here, and there's like an instruction pointer. So like one of them is going to be the current instruction, and so we're going to highlight that a particular color, and then we're going to step and it's going to move forward. And then occasionally you're going to find one that is not a primitive. So we're going to introduce things that are not primitives, and we're going to move, basically we're going to move those things from recursive Smalltalk methods into the language so they can be recursive fourth things. Okay, so that's, so the structure is going to be like this. I'm not exactly sure the right way to build this right now, but okay. Let's do this. Work area, add child, I'm just thinking a lot about. I'm just going to add like the word stack here. VL text element new text element new. Was it label text stack ops. Let me just put all the things that I want to have. We're going to have add children. So we're going to have step, a step button, and then we're going to have the ops. Right, what else? Obviously, that's not a user interface, but I don't know. That's what I'm picturing right now. Why it doesn't like that? Text must be an instance of text. As roped text. As roped text. Have my own little element or all the text shaped it up. The text and ops are going to be here. When you click on step, then we're going to move through the ops. Okay. All right, so so inside RPN now, let's actually make a new tab for this. So Vex RPN builder. When we initialize it, we have the stack, and we have the base, and we have the nodes. I'm not sure if the builder and the interpreter should be the same thing. Let's just say they are. This is going to be the interpreter for the language right now, right? For now. Well, actually, let's recategorize something. Right, so this is an ops. It's an op. Base is not an op. Bin op is not an op. BR op. These are all ops. Dupe is an op. They're all primitive ops. I is the primitive op that puts true on the table. O is a primitive op that false on the table. Push is a Smalltalk thing, so it's an internal. Simp high, simp low, and swap high, swap low. These are ops, but they're not going to be ops. They're ops at the moment, but we're going to turn them into something else. But for now, they are ops. These are going to be definitions in the language. Top of stack is a small talk internal, VM internal. So these are all just built-in constants that put individual things on the stack, and XOR is an operation. Right, so if I browse now, we've got ops. Right? Oh, branch should not be an op. Branch is just accessing. It's not really accessing, like a, I don't know, internals. Microcode, right? Whenever I make something like a VM, I think of it as code, as ops, and then microcode. That's kind of microcode. This is the interpreter, right? Okay. I'm not sure run is the right word, but yeah. So here's how here's how it's going to work. You've got a for every definition in the language, or like a function that we're going to define, it's just going to be a flat list of symbols that we then execute. So just like here, we broke this up. This is a flat list of, we turn this list of strings into what was the word? Substrings. We take this. So then if you collect as symbol, right? So if you do this, then you inspect this, you'll get a bunch of symbols, right? And so we have this list of symbols, and this is basically a stack frame, right? The stack frame is, well, and that's not the right word. This is the definition that we're running. And so the top level definition needs to be like available to right. So there'll be a dictionary that contains names. So the name of the word that you define is going to be defined as a list of symbols. And then you just go through and you execute each symbol, right? Okay. And then each one of those symbols is either going to be a primitive operation or it's going to be one of the names in the dictionary. Or it's going to be, well, yeah. So like, usually the convention in Forth is to, a Forth-like language is to use the colon as a definition language. That's not a valid name in Smalltalk. It is about. I mean, it is a valid name. You can put a colon in there. You can define it. I believe you can define a definition. Well, actually, colon is special because it's used for this name. I don't think you can define a method with just a colon as a name. Any other symbol you can, but I don't. Well, actually, the symbols as like the plus sign, you can make a method here. Okay, but we'll you can certainly have a symbol that is we can explicitly check for that. Anyway, what we want to do here is we definitely want to say run. So we're going to keep this. We're going to pass this in exactly as it is now. but we're gonna break these into definitions in the language. We're gonna replace swap high and simp high and so on with definitions. And the definitions are gonna look like something like simp high. And if you wanted to put like a comment in there, you would do it like this, where this is a special symbol. So this is a special symbol that starts a definition. This starts a comment, and then we just read forward until we get to this. Ignore all the symbols until we get to this. And then this is the end of the definition. Right, and then you put words in here. Okay, 0, x1. You could call this like init, right? And put this at the end. And then here you would say init. And then that would be a different thing. This would be loaded into the dictionary. That's the plan. That's where we're stepping up to right now. So the way to build that is you have the two stacks. You have this. The reason you can get away with only having one word for your thing, you don't have any arguments, is that every definition or every function takes a single argument, which is the stack of data. And so that's what we're calling stack here. But once you introduce control flow, you need a second stack, which is the return stack, the control stack. So we're going to call this the data stack. Yeah, we'll call it data. And then we're going to call it control equals also a stack. Okay. And so that is another spot. So fourths have two stacks, one for control flow, one for data, and then a dictionary that has the names. And so then the names are going to be defs, and that is a dictionary new. And then in this particular case, we have two other things. So this right here, data, control, and defs, whatever you choose to call it, that's like the core of a fourth interpreter. We also need an instruction pointer. So IP equals 0 number. As well. All right, and then these things. So base thing that builds. This is the thing that builds the. The base builds the actual data structure. Generated nodes do I use this? I don't know if I use this. References? I never use this. Yeah, so the base, everything is internal to the base. Right, so we don't need that, and we can get rid of this. Get rid of this thing called nodes. We also have two registers called high and low. Which just contain nodes. And the current branch variable is stored in here. Data is the stack we just made. Control is the stack we just made. Defs is our dictionary. IP is the IP address. Okay. Okay. think this is good. And then the rest of this, the rest is our fourth-like interpreter. Normally, in a real fourth-like interpreter, you're just dealing with RAM, right? You don't have a dictionary data structure. You have RAM, and you have cells in memory, and then you can jump back. So you wouldn't even have this. You would just have a stack, and you would have the control stack, and then you would have RAM. So instead of defs, you would have just plain RAM, and maybe at a particular spot in RAM is the start of a linked list, which you then can traverse backwards to, and that is your dictionary. So the dictionary is just a linked list of definitions. I'm not going to do it that way here, because you have to do a lot of low-level work, and this is a extremely high-level kind of language. So I'm going to store everything in just a dictionary, but we do need to have a spot to put the instructions. So I think I'm just going to call that the what do I call it? This the call it RAM. RAM, right? Like just RAM. Token buffer, tokens. Call it tokes. Tokes for tokens. And that is going to be an ordered collection new. I mean, that's the instructions, right? Like, so it is RAM. It is ops. I could call it ops. Tokens is fine. Call it tokens. Tokes. I might change that later. So anyway, these are the instructions that we're now stepping through. In a more print, like, so I have another project called B4, where I actually start with like a very simple virtual machine that has some like basic instructions, and I build a fourth on top of it. That's another thing I want to make a movie about. Another reason why I don't mind, investing some time into animating and drawing a fourth interpreter here. Anyway, so like when you do it like that, you build all this up from scratch, and here, and so your RAM contains like all the definitions and all the the dictionary stuff. But here, so a dictionary could be, because the reason is you're going to have a list of you have to have a stack trace, right? We want to the control stack. What does it contain? Well, it needs to contain the instruction pointer. So as you dive into a function, you have to push the instruction pointer onto a stack. You push the instruction pointer onto the stack, and then when you return from the function, which is when you encounter that semicolon, you get to the end of the function, you pop the previous place off the stack. And in this case, I think what's going to happen is like the list of tokens, like this dictionary is going to map a token, a name, to a list of tokens that get executed, and I'm just going to push that list onto the stack, maybe with the name. And so maybe we need to know the current function name, so the context is the how do you do that? How do you top? Right, so this is the name of the function that we are currently in when we start. Right? Because I have to push those two things onto the stack. I have to push the list of tokens and the IP and the context. These three things onto the stack. In this, because this is such a high level thing, add slot. Right, so these three things are what a stack frame is. This, and the list of tokens, which is kind of weird. You would never do that in a real low-level machine. So this is the stack frame, and so there are no variables. This is the control stack frame, and then this is the stack machine itself. So all the definitions are there. And then yeah, I like that. Okay. Then when we say run, what we're really going to say is self tokes is equal to ordered. Or we don't even have to make a new substring. We're going to say self reset. So basically self. We're going to say IP is equal to 0. Oh, we'll reset the stack. Self reset, which is going to be can do this. It's going to say IP is equal to 0. Context is equal to top, and tokes is equal to an empty array. Okay. Which is what this would have been. Ordered collection is like a dynamic array, right? We can call reset here, self reset. Self reset. Stack frame, self reset. So this destroy all context about the running program and read input. Okay, that's it. Or not read input. Run. Reset. So self reset. And now the tokens, we don't even call it tokes. We just say, we don't need the word self. We just refer directly to the thing. So we're going to say a string, substrings, and then we're going to collect as token, as symbol. Okay. And then actually we're going to say self tokes. We won't do it that way. And then we're going to say right. So the mistake is that I put that there. And then we're going to issue an event. We're going to say self fire. Oh, this is just an object. So a fire event is something that an announcer does. So we need an announcer. As this changes, we need to update the debugger. So this is a like the observer pattern. So make this observable. Make this observable to the debugger. Make ourselves observable to the debugger. So this says announcer announcer equals announcer okay. So we're going to have an announcer, and then we will tell this announcer. So announcer announce stack frame. So we'll say Bex stack frame changed event new. And probably we should send this as well when we just do reset. So we'll send 2 of them in this case. So we need to make this a new class, right? And it is just an event, right? Announcement is an announcement. And so then we need to go. We can just browse anything, and then we switch over from that class to this. We're going to look at the. What am I looking for? The uncategorized, no, maps, the debugger panel. So nRPN builder, and then we say RPN when. Is that built in? Is when do? Is that? Hello, Celine. You going to sleep? What's going on? Okay. Okay, well, I'm going to wrap this up in a little bit. I guess I'll make this the 2-part video, okay? Okay, so just give me a few minutes and I'll wrap it up, okay? All right. You don't have to stand there. Okay, I guess she's going to stand there. The girl staring. Okay. It's spooky. All right, I guess it is. I'm past my budget. I've only been at this an hour and a half. I guess it's bedtime. Okay. So it's bedtime, so we're gonna be wrapping this up for now, and we'll do another session later. But I do want to wrap this one thing and make this work. So we need to make a method called. Want to come learn some small talk, baby 17? When? Ah, you can't come in here, little baby. You don't have any clothes on. You got a diaper on. Do a block. Then we will say announcer when and event do a block. So we're basically going to make that something that the RPN builder appears to do itself. We can just call this like events or something. I don't think Sabine is learning too much small talk right now, but so then when the stack frame changes, then we will do what will we do? We will say self update stack frame. I at least want to be able to step through this, right? So update stack frame. So we will make a new method here. I will wrap it up in a minute. I'm sorry, baby 17. You guys have to just wait. It's going to be a couple minutes, okay? We draw a stack frame. I'm in the middle of something. I'll show you what I'm doing. Initialize. All right. Then we have a, so this needs to be a work area. Add child. We need to have a BL vertical, sorry, a BR vertical frame. Vertical, BR vertical what? pane. VR vertical pane new.
Why I got like on?
Why?
That's that right.
And we're gonna have self make buttons. I have the light on so that it does the green screen, baby. Self make. We have the buttons for the controller, and then we're gonna have self make make stack frame.
Mommy.
Okay. Very difficult to understand all the things that are going on. Okay, so we don't need this anymore. This is going to be make buttons. This is going to be make stack frame. Missing opener for closer. We don't need add child. We need this here. Okay, they're just going crazy like that. Make buttons. Create method make buttons. Sorry, my love. So buttons is going to be this. That's the button right there. Boom. For now, that's where the buttons go. Right, that's undeclared temp, so that's going to be a spot in the thing. And then make a new stack frame. Create method make stack frame. And the stack frame. Stack frame. This is going to be a BL VR horizontal flow. That's something that flows back and forth like text. New. And then add child, and then we will add this thing as a child. So the stack frame will just be the initial child right here. Simmy Jimmy, it's okay. What's wrong? Why come you don't have a shirt on? Go get some clothes on. Stack frame. Okay, so then when we say redraw stack frame, we can say stack frame. Stack frame. Remove children. And then add children. And we're going to say tokens or tokes. And tokes is going to be RPN. So we have RPN from here when we get sent. So so when we actually send the RPN builder to this thing. So we're going to say RPN current tokens. Sure. RPN current tokens, which is going to be a thing over here. RPN, current tokens. And we're going to just return for now. These are some tokens. And we're going to just, I'm going to draw this and then I'm going to, because I gotta go. So RPN current tokens, that should return that string. These are some tokens. And then for each one of those, we're going to make a little box. So tokes collect. And then for each one of those tokens, we will say PL text element. Actually, we'll do a GS text shape. GS text shape, because then I can put a border around it. New. Almost to text. And I don't have to use this. And then we can say that's the toke as string. And then GS fill. We'll put a little tiny border around it. Is it border? GS stroke color. And then EE. Text shape new GS stroke color. Stroke color. That's it. And I think that should make all the things. So I expect to see, when I run this now, I expect to see these are some tokens. No, actually, what I expect to see is I expect to see I expect to see tokes. Yes, what I expect to see tokes. I just want to return this internal thing tokes, whatever that is. And that way, when we run this, it should start out empty. So even though it initially says stack frame, that should immediately get wiped out. It should be empty, and then as soon as we run the thing, it should say what the tokens are. Announce was sent to nil. All right, so reset is being called inside of initialize before we have the announcer. So let's put this up here. Okay, restart. Let's just restart. Ah, come on. Okay, well, apparently that crashed this thing. Well, okay. I can see even OBS is freezing up. So everything is freezing up on this computer all of a sudden. So that must have gone into an infinite loop and is just going nuts. I'm not able to break it. I'm going to have to kill this, and I guess we will find out tomorrow if that works. So tune in tomorrow for the next exciting episode, and we'll figure out what happened with the debugger, because it really should be showing a debugger right now. Everything is just crashing on my machine. All right. Don't know what else to do here.